I'm Brian Sampson.
And I'm Ron Gordon from Mainline.
And this is a Mainline Solutions Short. Ron and I were just talking about high-performance computing and Nvidia and IBM Power and some of the developments that they have been working on together. Can you take us through that, Ron?
Yeah, and I like your intro to say high-performance computing, because this is purely a discussion on high-performance computing. And Nvidia is probably the world leader in graphic processing units. Now, these graphic processing units today have about 4,000 cores in them and up to 16 gigabytes of memory.
Wow.
So what happens in this architecture, which is basically an x86 architecture, I have a central processing unit that has multiple cores. It could have 12, 28, 32 cores in the one chip. But the way it has to function from a high-performance computing standpoint is that I have to get data out of memory and put it into the GPU. Now, in the x86 architecture, nominally, the transfer speed between real memory and the processor, so it can be put down into the GPU, is at about 80 gigabytes per second. Now, because in the x86 architecture, the GPUs are on PCI adapters in the PCI slots,
Sure.
They transfer at PCIe Gen 3 speeds, which today has a maximum of 32 gigabytes per second. So we could do arithmetic and say, if I have to download 1 terabyte of data, but these only hold 16 terabytes, that means I have to do a lot of downloads. And if I'm doing a lot of downloads at 80 and 32 gigabytes per second, it's going to take an amount of time.
Correct.
Once you get into the GPU, the processing speed is very, very rapid. But now the data has to flow back, because it has to be stored back in real memory so that you can determine what your computational result was. And this is the architecture that's been around on Power 8, all x86 systems, and is still in vogue today. But Power 9 developers and IBM got together with the Nvidia engineers and said, we'd like to accelerate this because the new workloads that are coming, machine learning, deep learning, artificial intelligence, require much more computations, because the amount of data we're working on is up in the hundreds of terabytes and potentially petabytes.
Oh, so further complicating with the slow speed between these. Okay.
Right, well, if you don't care if you get your results in 2 weeks, that's fine,
Gotcha.
right? Because doing it by hand would forget it,
Yep.
right? So this was great until you can improve it. So what IBM did is they took the identical GPUs, but they put them on the motherboard. So no longer are these in PCI slots.
Okay.
They're right on the motherboard or the planar. And the other thing they did is they worked with Nvidia and moved a technology called NVLink onto the processor by using some of the transistors that weren't being used. I'll just leave it at that.
Okay.
So now when the CPU wants to put data into the GPUs, it does not use the PCI bus. It uses NVLink, which goes down to the GPUs. Now, how fast do you think that is? If I make this faster than 32 gigabytes,
Maybe it's 64,
keep going.
100, 200,
Let's-
300.
300. So NVLink will now run at 300 gigabytes per second. Now, if you just do simple math, I can download data to the GPU 10 times faster.
10 times faster, yeah.
And I can upload it 10 times faster. So in a sense, you're going 20 times faster by using NVLink to the GPUs on the motherboard.
Well, that cuts down one of the links. How about the other?
Very observant. Now, in the power processor, I still have RAM, and I connect to the processor at 115 gigabytes per second. So that's faster.
Sure.
Not a lot.
Relatively.
Not a lot.
Wow.
But the other thing that is done here is inside of the GPU, there are level 1 and level 2 caches. And because you got multiple cores in here, to keep these synchronized, they do something called cache coherency, which means as something changes in one cache, it automatically changes in the other cache. They took this logic and extended it so that the memory in the GPU is coherent with the real memory.
Near instantaneous.
Oh, near.
Near. Okay.
Not zero. But this
That avoids that
is
bus.
only a download issue, not a put it back.
Gotcha. Okay.
So what they've done is they've done benchmarks on this. So this Power 9, they ran a benchmark. This may sound extraordinary, but in this x86 world, they ran a job that took 7 days. Big job. They put it over here, it ran in 11 minutes.
Wow.
If this system, Red, costs the same as this system, this performance is incredibly beneficial. Same amount of money, and you get the results quicker. If we take a look at somebody potentially, this is made up, but it's not unrealistic. You go into the doctor's office, and they take a DNA or a blood sample, and they're checking for, heaven forbid, something like cancer through cells. And they say, Brian, come back in 7 days and we'll have the answer. As opposed to, wait a couple minutes, I'll come back and tell you what we find. Just think of the ramifications of that on medicine.
Sure. Now you said an if. I'm assuming it was a rhetorical question that you were asking, but they are the same cost? In certain situations they can be?
There's a lot of variables.
Okay.
All right? These GPUs cost between $11,000 and $17,000, but they're the same GPUs from Nvidia. So the cost of these is basically the same. If you take a look at the Power 9 systems that are coming out very soon, the one that's out today is called the Accelerated Computing 922. That, unlike an HP DL380, this is less expensive.
Got it. So,
But, you know, how much memory did you put on? How many? So for all intents and purposes, I'll say they're the same.
So Ron, sounds like Mainline can certainly help with understanding whether or not your current environment could be migrated easily into a Power 9 high-performance computing environment and save a lot of time and money.
Absolutely. We have the technical skills to bring this to any of our customers that are interested in high-performance computing.
Fantastic.